Hi everyone, thank you for joining us for our webinar, Certified Functional Safety with Qt Safe Render. My name is Erica and I'm going to be your host today for the Zoom platform itself. Just to do a couple house cleaning items before we go to the meat of our presentation here. First of all, we are recording this webinar. We will be making it available to participants within the next couple of business days. Also, if you have any questions, we do encourage you to ask them. You can ask them in the Q&A box at the bottom of your screen. You should see a box with a Q in it to be able to click on that. We will be answering all questions at the end of the presentation. So with that, I'd like to hand that over to our speaker for the day, Tuukka Turunen. And Tuukka, I'll let you take it from here.
Thanks, Erika. So, hello everyone. My name is Tuukka Turunen. I'll be talking about how to get certified functional safety with Qt Safe Render. The presentation will be about 30 minutes or a bit more, and then there will be possibility of asking and answering some questions at the end, if there are any coming from the audience. You can write the questions during the talk at whatever time, and I will then look at them towards the end of the presentation. So first we will be discussing just briefly on what is functional safety and what kind of safety standards there are. Then we look into a few different ways and architectures how to create a certified system with Qt. And then we dive into the Qt Safe Render version 1.0, which is currently available, and then the upcoming Safe Render 1.1. And then summarize and have some time for questions at the end. So, what is functional safety? The goal for functional safety is to protect people from getting hurt. It is always based on active systems to detect and prevent problems. So, if you have some passive system, like let's say, if you make a saw, you might have a ways to not put the fingers in. That typically isn't considered functional safety. Rather, it is a bit more advanced systems that are then there to see and possibly unsafe condition and then take actions to prevent them. The picture that is shown, you can see that an accident has happened, but and there's been quite a lot of damage to the vehicle, but the driver, which is there, seems to be relatively in good shape, probably feeling a bit sad about totaling the car, but otherwise seems pretty good condition considering how bad the metal is. So there has been, in this case, multiple different systems probably operational and successfully preventing the person from getting hurt. The functional safety is measured by safety integrity level in automotive safety integrity level, which is determined based on how likely your system is to cause an injury or death. So in this presentation, I don't go into the mathematics of it and how to determine, but rather we can approach typically from the viewpoint that in different kinds of systems there is a level where you want to go, and then the solutions that you take need to be done according to the level that you want to reach. Different industries have different standards. The main standard for functional safety, kind of a mother of all standards, is the ISO 61508. In some industries, that can be applied directly, and in some other industries, or in some industries, there is a derivative of this standard in use. Some provide just a small additions or clarifications over the 61508, and some are rewriting it, but the same principles apply. So let's then take a look into what it takes to create a certified system with Qt. So first of all, the complete system needs to be certified. So it is good to use pre-certified tools and components because that helps in certifying the whole system, but it doesn't, even if the system is completely built from pre-certified parts, it still doesn't mean that the whole system wouldn't need to be certified. It just makes the certification easier. Another important aspect is the separation. So when making a system, typically always there are some functionality that is safety critical and some that is not. And if the system architecture can be done in such way that the safety critical parts can be separated from the other parts, it means that the certification activities can take a deeper look into the safety critical parts, and for the other parts it is adequate that they just do not interfere or cause harm for performing the safety function. And with this approach, it's completely possible to use the full Qt in the system without any changes to Qt libraries in the non-safety critical part. And then for safety critical part, if that consists a user interface, you can use the Qt safe render. If the safety critical part does not contain a user interface, there might not be any need to do with the safe render itself. The separation is adequate. I will look into a couple of examples and architectures how this is done. Typically, in conjunction with when Qt is used, the system does contain a user interface, therefore safe render is often very much needed. So let's take the first look into a simple architecture where we have a real-time operating system that is certified to provide the separation between the safety critical and non-safety critical processes. In this example, we are using regular Qt libraries running on top of the real-time operating system and for creating the main UI of the device, for example, with Qt Quick, could be widgets as well, it doesn't matter. And then we have on the safety critical side, we have the Qt safe render and then the safe UI created with that. And the real-time operating system is doing adequate separation for the processes. Therefore, no other criteria is needed. In the higher levels of safety, this approach cannot be used, but in many cases, the required level of safety is adequately low for being able to use a real-time operating system for separating the safety critical and the other functionality. And as I mentioned in the previous slide, of course, it could be that there is no safety critical UI at all needed. The safety critical functionality could be something other than UI related, or the safety critical UI can be created with, for example, simple warning light or similar. In that case, the safe render is not needed, but in many cases, it is beneficial to have a bit more user interface created for the safety critical functionality, and then using the safe render is very valuable. If we take another architecture with a bit more complicated device, we have a hypervisor, so-called type 1 hypervisor, providing the bare metal hypervision and separation for operating systems. On the safety critical functionality side, we have again a real-time operating system certified for functional safety, and on top of that we have the Qt safe render and the safe UI. There can of course be, and typically is, other logic as well to get the events and to react to the safety functions. And then in the other functionality side, we have a non-certified operating system, for example Linux, and then again Qt and the main UI created with this. So pretty similar architecture as before, but instead of having the operating system to provide the separation, we have a hypervisor to do that. And obviously, the hypervisor there needs to be certified, either using a pre-certified hypervisor or when creating the system, then making sure that the hypervisor can be certified for the safety on the system level. Then a bit more complex example where we have again a hypervisor, but we have also multiple domains of the UI, and this is in a way a combination of the first two approaches. So we, on top of the hypervisor, we have the operating system that is not safety critical, that, for example, Linux. On top of that, we have a user interface, done with Qt, and then on the safety critical side, we have the real-time operating system, which again has another instance of Qt and another UI of the system created, which is non-safety critical, and then we have the safety critical UI created with Qt Safe Render. And the benefit of this is that we can still use the same SoC, same hardware. No need to duplicate the hardware between the different systems because the adequate separation is created by the hypervisor and the real-time operating system. It is completely possible to do the separation also in hardware. So basically, we in this, instead of hypervisor, we have completely separated CPU. They can be on the same silicon. Some silicons provide, for example, a microcontroller or similar to run the safety critical functionality, and then a more powerful CPU to run the other functionality. In this, we have the real-time operating system safety certified, and the Qt Safe Render and Safe UI running in one processor, and the other functionality, for example, Linux running Qt and the main UI on a different processor. So that was a quick look into a couple of different architectures. Let's next dive into the Qt Safe Render and see how that can be used to create the safety critical UI. So first, the Qt Safe Render has been certified. We got the certification through in May for the version 1.0, according to 4 different standards for functional safety, which are listed, both of course in the certificate itself, as well as on the left-hand side. So on automotive, we are certified to ASIL D, which is the highest level. And then on the 61508, it's the second highest, so basically SIL 3. On railway, we are on SIL 4, which is pretty high, again, the highest for the railway safety. Then there often is a question that what if I only need, for example, ASIL B? What can I still use the Safe Renderer even though it's certified higher? And the answer is that yes, of course. So we have certified the Safe Renderer as high as it was possible to certify. In typical cases when user interface is needed, you don't need to go to ASIL D. ASIL A or B for automotive are fully fine. Same often for the general industry standards, so SIL 1 or 2 often are completely fine. So it doesn't cause you any issues. But in the other way around, if Qt Safe Renderer was not certified as high as you want it to, then you would take additional steps in certifying the complete system. Often when you build a system, you might need to have, for example, like if you want to reach, say, ASIL B, that of course means that you should pick the real-time operating system, for example, that meets the ASIL B requirements and graphics and similar. And then the Safe Renderer, in conjunction with this kind of system, operates according to the ASIL B requirements, which is then set and provided by the other components in the system. So, what does the Qt Safe Renderer contain? What does it do? It contains 2 certified components. It has development tooling that integrates to a visual designer of UI, and it contains a rendering component for the safety critical UI that runs in the target system. It provides integration to the real-time operating system, for example, QNX 7 and Integrity 11, and or the safety variant of QNX 7, obviously, so Safety 2.0, which we are certifying with the 1.1 release. And it runs on multiple different hardware, a couple of examples there, but basically you can run on whatever hardware is supported by those real-time operating systems that we run on. And as I mentioned, it's certified according to multiple different standards. On the pictures, on the top one, you can see an example of the Qt Designer tool that you can use to design the UI, both the safety critical functionality and other functionality. And then on the picture below, you can see the complete system running on an IMX6 hardware. Convenience for creating the safety critical UI is the most important thing that we wanted to achieve with the safe renderer, in addition, of course, being safe and filling the criteria. Because often the safety critical software is quite difficult to use. It might be cumbersome to change. And we wanted to, being a tooling company, we wanted to change that. Therefore, we created the setup in such a way that you can create the safety critical UI as easily as you do other UI with Qt, using QML, Qt Quick as the language to describe it, using our visual design tools to create a safety critical UI as well as the other UI. And then tooling that separates during the final build the safety critical parts from the other parts, and then prepares them for being rendered with the safe renderer. We have also added a convenient library for different ISO icons. For warning symbols, you can obviously use also other symbols. This is just a standardized set of multiple icons that can be rendered with the safe renderer. As I mentioned, you can design fully in QML. Here are a couple of examples of safe QML types that you can write into your code or design with the visual designer, and then the tooling will not notice these and take these out from the QML part and create corresponding safety critical parts. So we are not running QML in the safety certified parts, but we are using QML as the tool with which the safety critical UI is created alongside the other UI. And then on the rendering part, it is done using a MISRA C compliant renderer component. Here is a picture explaining the same thing. So on the top, you can see during the development, you can do just a normal build for desktop. Everything is QML, also the safety critical parts. You can prototype, you can iterate, and then when you do build for the target, the tooling will split the safety critical and the other components, and the safety critical parts will be created and put to the safe renderer to render, for example, the telltales, whereas the other UI parts are rendered by normal Qt. And this has the added benefit that when you want to change, not if, but when, there comes a need that, hey, actually make those icons a bit bigger and move them to top instead of bottom. So you can just do the change in the tool like you do for also all the non-safe components, and again do a build, and the safe renderer can render these without any changes to the safety critical code, fully generated. So you don't need to touch at all, you don't need to recertify at all any code that you have written for the system. Safe critical UI in the version 1.0 renders bitmaps as well as text-based baked into the bitmaps, and I will be talking 1.1 a bit later, where we increase a bit more advanced support for text. The renderer is created with MISRA C++ 2008, fully compliant with that specification. We have done extensive testing and a lot of documentation. So as part of the Qt Safe Renderer, you get full safety manuals, you get all the testing documents, all the certification assets that you can give to the certification authority when you certify your system. And similarly, you get those for the other parts like the real-time operatings and so forth. And with that, the certification of your complete system is much easier. The runtime architecture of Qt Safe Renderer is shown here as an example. So the safe renderer has no dependency to main UI. The real-time operating system separates it fully from the main UI. It can listen to the heartbeat from the main UI, which often is valuable, because with that way it can detect possible problems in the main UI. And it can also control the main UI. But the main UI doesn't control the safe renderer, because then it could cause problems if it would do the controlling wrong. So it does send heartbeat, which allows the safe renderer to react. And also in this picture, we are explaining how it is drawn to different layers. But let's look a bit into the next slide, where the layering is maybe a bit more visually represented, because that's often is a question that what if the other UI goes just completely crazy and draws over the safety critical UI? How to prevent that? So this is done typically by drawing the graphics into different layers, and most modern hardware supports the layered graphics, and all the certified chips that was mentioned, they all provide this capability. So we basically give the hardware topmost hardware layer for the safe render to render. Therefore, no matter what is drawn into the other layer, it doesn't overdraw. So this way, it can be made sure that the safety critical parts are always visible. Typical operation of the Qt Safe Render is done. Here's a sequence diagram explaining the operation. Is typically done in such a way that the communication of the main UI and the safe renderer are minimal. There's no dependency. So when the safe renderer gets an event from the safety critical part of the system, for example, an interrupt or whatever level, you might have some protocol implementation that listens to failure states. And then when it has the event, it will start drawing. So the safe renderer is, as it names, suggests, just a renderer. In addition, you will need to create the code that commands the renderer to render into the safety critical side. So that can be pretty simple if you have only simple needs for the rendering. And if you have multiple different fault states, multiple different bitmaps, then of course the complexity of the safety critical code grows. And there's no limit in as such how much the safe renderer can render. It depends on the system needs. So it's very flexible in that sense. In here, we can see an example how the main UI recovery works. So basically, the main UI sends the heartbeat, and watcher is listening to the heartbeats. If there is no heartbeat within a given time frame, then it can start the main UI recovery process, as described here. It will be able to ask the main UI to restart, and it can also display a message, an error message, or similar, to react so that the user knows that the main UI has been lost. With the 1.1 version of the safe renderer that we are currently developing, you can do a bit more. But first on the availability. So our current understanding is that we will be able to provide the version 1.1 with the same levels of safe certification that is available for the 1.0 during the first quarter of next year. So we are currently in the testing phase, and during November we expect to be able to send all the certification assets to the certification agency, and then depending on their schedules and depending on how many rounds we need, there will be then some iterations, and after that the certificate is expected to be granted to us somewhere during the first quarter of next year. The three most important features that the Safe Renderer 1.1 adds are the dynamic text renderer, which extends the safe text functionality of 1.0 so that we can provide dynamic text. The text content and color can be changed. This, of course, allows also to show numbers like the speed, for example, or dosage. Another important is that it supports large icons. So in the 1.0, we had the limitations of the icon size so that it was mostly for the telltales, but now we can provide large icons, for example, to draw the background, which makes it easier to create a safety critical UI, especially in the failure state. And then we also provide the possibility of overlapping icons so that multiple telltales can be toggled in the same position, unlike in the 1.0. In the picture on the top right-hand side is an example of a safety UI that can be created with the 1.1. So the large icon support allows to draw the background, which is good in the sense that even though, for example, in this case, we have lost the needles of the gauges, the user still sees the outline of the instrument cluster, making it more easily to understand that the system is still operating, but it has gone into an error state. We use the text functionality to draw the recovering message, and that can also, of course, display multiple steps of the message. And we use the dynamic text capabilities to display the speed. Equally, we could display, for example, the gear information and other things that are considered important to give to the user even in the failure state of the system. And of course, the telltales, just like before, but now also possible to overlap and create multiple icons to the same location in the screen. So moving to the summary part of the presentation. So the objective of the functional safety is to avoid unacceptable risk or injury to people. So it has active systems that try to detect a state that can be harmful and then act accordingly to avoid or minimize the harm that is done to the people. There's multiple different standards. The industries that you are working on and the regulators set the standard and demand what your system needs to be filled. So you typically don't need to, when you create a system, you don't need to fulfill multiple standards, but from the Qt viewpoint, because we work and create solutions for so many different industries, we have chosen to certify the Safe Renderer according to 4 different industry standards to get the wide coverage of different needs for the functional safety. Always the complete final product is certified. You can use the Qt Safe Renderer to create the safety critical UI, and it's beneficial to use pre-certified components such as the real-time operations hypervisor. If you don't, it's not necessarily mean that you cannot certify the system. It just means that you need to do quite a lot more paperwork. So in practice, those are often used. Qt as a technology is well suited for certified systems in such way that you do the separation between the safety critical and other functionality. And this allows you to use Qt without any changes in the other functionality part, and then the Safe Renderer for the safety critical parts. And then obviously, as I mentioned, we have the 1.0 available now. You can take it for a spin, contact our sales, ask it for evaluation, try it out, and 1.1 is under development and coming quite soon with those couple of added features that I described. And the assistance for further needs is available through our service organization. So this was a walkthrough of the Qt Safe Renderer and creating safety critical systems with Qt. I described the 1.0 version and also a bit what is coming in the next version. during the first quarter of next year. Now we have quite good time for some questions. If you have any, just type, and I'll be happy to answer. At the moment, I cannot see any questions asked, so there's nothing to answer yet, but I'll be happy to answer if any one of you want to type those. Okay, if not, then I want to thank you for the interest and joining the webinar. Oh, we have a question. Yes, the question is, are there any other safety certified real-time operating system options in the pipeline? So currently we are working, we provide the out-of-the-box support for integrity and QNX, and the QNX OS for safety. But of course, we are always happy to hear about the other needs. And if you have an operating system that is certified, it is probably rather easy to run the safe renderer on that operating system. For the other parts of the Qt, it is a bit more tricky. So if you would use some of the other real-time operating systems that do not already contain the possibility of running Qt, you probably would take the architecture that you would run Qt, for example, on Linux, and then only the Qt safe renderer would be run on top of the other real-time operating system. So there was a question, for example, towards safe RTOS. So should be pretty straightforward. We haven't tried it, but as long as the real-time operating system that you have can run Mitra C++ code, which typically they can, then it should be able to run the safe renderer. There might be some testing involved, so we have provided the full testing on those platforms that we are supporting. So you would probably need to then need to prove on the system level that you have tested adequately, that all the corner cases are filled and so forth. But other than that, I see no problem in using whichever certified real-time operating system. I mean, basically, Qt Safe Renderer could even run without an operating system, just running on directly on a microcontroller. Then it's just the challenge in this case is that you often need to have some process to create the events with which we render, and then when you do that, you often benefit on having an operating system. But as a technology, to safe renderer would of course run very nicely, basically on anything. It's relatively simple render. So I hope this answered the question. So not out of the box, but should be pretty straightforward, and not a big effort overall to certify the safe renderer in other real-time operating systems than those that we support out of the box. And your certification agency would probably be happy to see the test results that we have gotten and the test cases that we have run on the other OS, and then you can yourself run the tests on the other, on your own real-time operating system, and when the results are the same, I wouldn't see any issue in getting the system certified. Okay, so, and that was all the questions that we had. Thank you, and the recording will be stored, as Erika said, in a couple of days. You should be able to get that. And of course, also, this will be later provided as an on-demand for those who weren't registered or listening, can still come and watch the recording later on. Thank you, and bye-bye.